Good morning. In this lecture, we will discuss lack of it, support settlement, and temperature effects in indeterminate trusses. Now, lack of it. Lack of it means if the actual length of a member is more or less than the desired length, it is known as lack of it. One or more members in a pin joint statically indeterminate frame may be little shorter or longer than what is required. Such members will have to forced in place during the assembling. These are called members having lack of it. For example, consider this truss ABC. A, B, C. Say both ends are hinged. Both ends are hinged and the required length of this AC is 900 centimeter. That is 1 meter. 100 centimeter. But the length as fabricated in the factory is less than 100, that is say just 90 centimeter, then we can say there is a lack of it for this member AC. Okay, also if the fabricated length is more than this 100, we can say there is lack of it. In that case, you have to force it in place during the assembling, force these members during assembling. That is, we have to, if the member length is 90 centimeter, you have to pull this member to make it 100 centimeter. The lack of it effectively increases the stress range over which a member may be loaded and the maximum load carrying capacity of the truss. That is, in this case, say member AC. This is member AC. If you are pulling this member, there will be internal stresses. That is, you are pulling this member to make the length 100 centimeters. So there will be internal stresses, tensile stresses. Okay. Then in the construction stage, and if you are applying some force and some stress values, and if the member is already stressed to a stress level of some value, some compressive some tensile stresses. Okay, so tensile stress of say 100 MPa, for example, say 100 megapascal. Okay, now if you are applying a compressive stress of 10 megapascal, initially there was a tensile stress of 10 megapascal due to pre-stressing. So if you are applying a compressive stress of 10 megapascal, the net stress will be 0. Means already there is a tensile stress of 10 megapascal. Now if you are applying a compressive stress of 10 megapascal, means the net stress will be 0. Okay, so the effect of 10 megapascal compressive stress will be 0. So if even if if you are applying more stresses, it can take. Okay, compared to other usual truss members, so it increases the stress carrying capacity of the truss. Also note that if the for a determinate truss, there will not be any lack of it. Why? For say for a determinate truss ABC, if the this is A, this end is A, this is B, and now the support is C. If this is roller support, roller means it can move in horizontal direction. Okay, now in this case, if the required length is 1 meter and actual length fabricated is 90 centimeter, no need to pre-stress this member. Okay, no need to increase the length or shorten the length. Why? Because this is roller support, it can move in the horizontal direction. Okay, so it will adjust, it can be adjusted to make required length 90 centimeters. So there will not be any effect of lack of it in determinate trusses. Effect of lack of it will be in indeterminate Stresses only. Okay. Now, what is support settlement? Support settlement means, say, if the support B, in the consider this beam, proper cantilever beam. In this case, if the support B settles by 5 mm, okay, see, say it is settles by 5 mm. Okay. Now, if you are using Castigliano's minimum strain energy method for the analysis of this beam, what you will use? Our equation will be, if there is no support settlement, our equation will be deflection at B, that is dou u by dou RB, that is integral m into dou m by dou RB into dx by A equal to 0, if there is no support settlement. And now, if the support settles by 5 mm, we should write delta B equal to 5 mm. Okay, that is, there is a net settlement of 5 mm. So our equation becomes integral m into dou m by dou RB into dx by EA equal to 5. Okay, now the problem can be solved as usual. Now, effect of temperature change and the lack of it due to temperature change in the analysis of indeterminate stresses using Castigliano's theorem. Okay, say if there is no temperature change. No temperature change means there is no change in length. If there is a temperature change, there will be change in length. So if there is no temperature change means Castigliano's equation will be sigma p into dou p by dou t into L by A equal to 0. And if the member AC has an initial deformation of 3 mm due to temperature change, then we should write for the truss member sigma p into dou p by dou t into L by A equal to 3 mm. Okay, if there is a change in length of 3 mm, and the problem can be solved as usual.